Hello everyone, today we're going to be talking about the big boy sine rule, and this is a rule in trigonometry that, unlike the area sine rule or cosine rule, does not have one equal sign, but it has two, and this is quite useful actually. So the sine rule basically means that a over sine a is equal to b over sine b is equal to c over sine c for every triangle. And the thing with the three equal signs is all of them are equal, so that means you can pick any two to be equal to each other and you can use that in isolation. This is really just a faster way of remembering all the cases that, for example, a over sine a is b over sine b, and then you'd also have to remember b over sine b is equal to c over sine c, and then you'd also have to remember a over sine a is equal to c over sine c. But then you could just remember it all in one string like this. A over sine a is b over sine b is c over sine c. It's pretty catchy. Alright, so what this basically means is that the ratio between the length of a side and the sine of the opposite angle is always constant. And we're going to set about proving that. So, Q. Prove that. So, how do we go about doing this? Well, as you might have expected, one of our first steps is going to be to draw a height of a triangle. I'm going to set about first proving that a over sine a is equal to b over sine b. Then I will prove that b over sine b is equal to c over sine c. And then the whole rule will have been proven. You only need to prove two of them to know that all three work, because of the property of transitivity, which is basically the result of having many things equal to each other. Alright, so say we label our sides A, B, and C. And we have our angles C, B, and A. The first thing we're going to do is we're going to draw in a height here from the side C to the angle C. And this will give us two right-angled triangles. So firstly, the height will be the opposite side against the angle B, where the hypotenuse is the length A. So there'll be this right triangle, and we know that since sine is opposite over hypotenuse, sine is h over hypotenuse, or rather sine b is h over a, h is a sine b. So we know that this is a sine b. And say we also want to find out that this height from the perspective of this right angled triangle. So we know that you have this side here, and there's A here, and angle A there, and length B there. You also want to find out this triangle, or rather this length, not a triangle, and you know that sine A is going to be the height over B, because B is the hypotenuse and the height is the opposite side of this triangle, and therefore H is equal to B sine A. And if we put it back into this big triangle, you might notice that these are actually referring to the same length. So we have proven that, geometrically, we have proven that A sine B is equal to B sine A. So to get it in the form we're familiar with, first we're going to divide both sides by sine B, and we get that A is equal to B sine A over sine B. And then next we're going to divide both sides by sine A. So we all have A over sine A is equal to B over sine B. Now we want to prove that B over sine B is equal to C over sine C. And it is largely the same drill. So say we take a height from, actually I'm going to redraw the triangle. So we have our three angles A, B, and C, and we take a height between B and C. You first have this right angle triangle here, where the angle here is C, angle here is B, where the angle of the right angle triangle is C, and you're looking to find the opposite side, and the hypotenuse is B. So therefore, I'm not going to go I'm not going to go through the process of utilizing the sine's intuition again, but then sine is opposite over hypotenuse, but so this is b sine c. And you look at the other triangle, and you also find out, since the hypotenuse is c and this angle is b, this must be c sine b. And you can do the same kind of division as we did in the first one, since we've geometrically proven that b sine c is equal to c sine b, we can divide both sides by sine c to get b is equal to c sine b over sine c. And finally, we can divide both sides by sine b to get b over sine b is equal to c over sine c. Right, so now we've proven this, and we've proven this. Therefore, we can make the conclusion that since sine a over sine a is going to be equal to b over sine b, which is also going to be equal to c over sine c, we have proven this big boy sine rule here. So what are the applications of this sine rule? Say you have to solve a problem that doesn't match the cases given in the sine area rule or the cosine rule. Like, say you have a triangle where you know this angle, and you know this angle, and you know this side. And they want you to find this side. For this kind of thing, this is where you could use the sine area rule. Or alternatively, say you have two sides and an angle that is not between them. So you know this angle, but you want to find out this angle. How would you go about doing that? Well, you would just use the sine rule again. And of course, the sine rule can be simplified, or rather manipulated, not simplified, to get you values for if you want to give it in, if you want to make a length or an angle the subject of the formula. So say you want to get the length a as the subject of the formula, so therefore you multiply both sides by sine a, and you get a is b sine a over sine b. A, B, A, B. A is b sine a over sine b. And otherwise, say you want to get an angle, so you want to make sine a or sine b the subject of the formula. Well, if you have a over sine a is equal to b over sine b, that means the ratio is identical. So what you can do is you can take the reciprocal of both sides, and you're left with sine a over a is sine b over b. And if we want to let sine a be the subject of the formula, we get sine a is a over b sine b. And I'm going to write this out because it shows really that there's a ratio between the two sides which is at play here. And if you want to get the angle A, the easiest way to remember it is that A is the inverse sine of A over B sine B. Alright, so it can be used in either this form or this form, and perhaps some other form for more general kinds of problem solving. Alright, so with those last words, I'd like to say thank you for watching.